but this is a talk that I just put together to give on cruise ships. And the actual title is called Science and the Hunt for Life and God in the Universe. And the reason that I put this talk together is because almost any time that a scientist comes on in front of a large audience and talks about any topic, there's somebody in the audience who's actually wondering, what does that guy think of God? Where does God come in? And I've always wondered the same thing. And most scientists are really hesitant to talk about that topic. But considering we just had a religious panel over here, and the guy who was supposed to be here for the next hour hasn't shown up, and I just put this together, I thought, well, let's give it a shot and see how you guys like it. So I gave this recently at the Lifelong Learning Institute, Asher Lifelong Learning Institute. And a lot of people came over and they really liked it. Unfortunately, there's a lot of videos that are missing, but I think you'll get the gist of it. So I'm going to give you the Are We Alone, the Yom Kippur Lecture. So how did that name come about? And the name came about, obviously Yom Kippur is religious, okay, but the name came about because the first time I gave this talk happened to be on Yom Kippur. And I was looking for a title, and there were a few Jewish people on board, and they said, well, what are we going to do today? And I said, well, I think I'll give you a lecture, and I'll call it the Yom Kippur Lecture. And so that's how it got its name. As far as, I don't know how many of you know the details of Yom Kippur in the Jewish religion. It's the Day of Atonement. And on the Day of Atonement, Jews ask for forgiveness for all the things that they may have done to offend people. And it actually derives from a prayer called the Al-Chat prayer, written by Anonymous. We don't know who that person actually was, but the number of things that you ask for forgiveness for are actually mind-boggling. So I'll read a few of them, okay? Read a few of them. For mistakes we committed before you, God, under duress and willingly, for mistakes we committed through having a hard heart, through mistakes we committed through things we blurted out with our lips, through harsh speech, through wronging a friend, through degrading parents and teachers, exercising power, for mistakes we committed against those who knew and didn't know we were committing an offense, for mistakes committed before bribery, denial, false promises, negative speech, food and drink, oh God, for being arrogant, for having a strong forehead, being brazen, for refusing to accept responsibility, for jealousy, for baseless hatred, by extending a hand falsely, confusion of the heart, and the list goes on and on. And now if any of you have ever wondered why Jews feel guilty, now you know. There's not a single thing you can think of that you shouldn't feel guilty about. So here we have this day called the Day of Atonement, where basically you sit all day long and you ask for forgiveness, right? So with that as a mind, to start this off, the question then becomes, whom are you asking forgiveness for? And that really is the essence of the talk. But before we begin, because the topic of this talk is the hunt for science and the hunt for life and God and the universe, it's important to understand what science is and what science isn't. And a lot of us just take it for granted, but the average person really doesn't have a clue what science is. So let's digress a little bit and talk about what science is. Okay, so it's a method of observing physical phenomena and behavior and predicting their repeatability. And how do you do it? Well, there's a set of rules, starting with an educated guess called a hypothesis, followed by a testing to prove or disprove that guess. And the results must be able to be repeated independently by outside scientists and laboratories. And these results must be publishable in peer-reviewed journals That is journals with non-aligned judges and nothing to gain. No book to sell, no product to sell. If you had to sum all this up and condense it into a single calling card, the calling card was coined by Carl Sagan. I like to use it because it's easy to remember and it gets to the point. Extraordinary claims require extraordinary evidence. So anytime anybody says something that seems weird to you or seems like there's a UFO up there or whatever it is, there has to be an extraordinary evidence to that, which means you really have to rule out every other possibility. There are different types of scientific studies. Basically, it comes down to two, cause and effect. That's in a laboratory. For every action, there's an opposite reaction. You can actually see the reaction, cause and effect. The other type, statistical, also called circumstantial, also called epidemiological. This does not take place in a laboratory. This is using a large sample size, very large sample size. Example, smoking causes cancer. Would you be surprised to know that nobody has ever seen cancer being formed in a laboratory from being exposed to cigarette smoke, cancer cells? No. The reason we know that is because hundreds of thousands, millions of people, there's evidence that this is what happens when you expose those people to those conditions. That's called statistical or epidemiological. Well, the next question about science that you need to know is the question is that it is not infallible. Results change. At one time, the world was thought flat. We are human, we make mistakes. Cold fusion is another example. The other thing to know is that claims and experts abound. Somebody who's an expert one day is a charlatan the next day. Everything I'm going to tell you sounds good. Come back in a year or two. Hey, what was that guy talking about? Think about multiverses. Think about parallel universes. Think about string theory. Think about all the stuff that physics tells us. Would you be surprised to know that none of it comes from observations, physical observations? It comes from math. It all comes from the math, and from the math, a physical entity or a physical observation is created. But that's not how we've learned to do most of science. Most of science is a physical observation, a lot of it. So anyway, the point I'm trying to make is this is not perfect. It's the best thing we have. And at the end of the day, remembering all this stuff is hard. So condense it down to extraordinary claims require extraordinary evidence. Before because I have extra time here, I'll digress a little bit more about the meaning of that and put it in perspective with Mars. I've got a pretty close friend by the name of Gil Levin. I've known Gil a number of years. Gil was one of the principal investigators on Viking. Gil had one of 3 experiments in 1976 that were sent to discover life. These experiments are all based on the fact that our kind of life, carbon-based life, uses respiration as a fundamental way of metabolizing. That means that we take in food, we metabolize it, and we burn it, and we produce carbon dioxide and water and energy. It's the old equation called respiration. Every one of us at some point or another came across in high school. Take food in the form of glucose, combine it with oxygen, which we breathe in, and on every cell of the body, we undergo respiration, which means those cells that glucose, that food is combined with oxygen and produces carbon dioxide, which we exhale, water, which keeps our body, which is over 66% water, continually nourished, and energy to produce the things that we do, to walk and do everything we do. So that was the basis of the 3 Viking experiments. And in the beginning, all 3 of them, the first day that the results came back, all 3 of them were positive, astonishingly. And they actually reproduced ground-based experiments on Earth as to what life would look like. And the scientists were out of their minds. This is incredible. But as time went on, 2 of the experiments did not repeat. And there was another Viking lander. There were 2 Viking landers, second Viking lander, and it didn't show the same repeatability. But you see, there was one experiment that never changed. It always showed life. It always reproduced pretty much the results that were on the Earth before the baseline testing. And in fact, when that experiment was, in the way Viking worked, it picked up a soil sample, it put it in an incubator and added water, and it had sensors and Geiger counters and things like that. And so when that incubator was heated up to 320 degrees, the signal stopped. And that's what would happen with life. It would die at 320 degrees. And another thing, people claimed, well, you're getting false results because you're looking at a highly oxidized surface, which has been baked by radiation in a low atmosphere. And so to counteract that, Gil, this is Gil, he used a robotic arm to pick up a rock, and he dug a sample from under the rock where it would not have been exposed. And so everything he did indicated life. But what happened, the essence of science here, is the other two guys ganged up on him. And then the result that came back was that there were alternate explanations. You have not shown that there is no other explanation. And that's where we get the expression, extraordinary claims require extraordinary evidence. And to this day, Gil Levin, who's pushing 90, will tell you, and anybody else that he will come across, that he found life. Life is on Mars. There's no doubt in his mind, and sooner or later we'll find this out. But extraordinary claims require extraordinary evidence. If there's any other explanation, then you really can't make that claim. So I'm telling you this, if people tell you things that seem a little far-fetched in their beliefs, that's what you have to say to them. That's what they have to prove. That's the onus on the person who makes that kind of claim. I could go on for hours about that, but let's get to the talk. Let's get here. The hunt for life, meaning in God and the universe. Looking outward, what do we see? Unfortunately, a lot of these videos don't play, so I'll have to just give you a capsule summary. The moon, we'll start at the moon, an incredibly interesting place. We've been there, or we may go back again. No signs of life. Mars, well, the debate really, as I've just couched it, is ongoing. It's a place that is not hospitable in many, many ways, but it does have water. That water can be liquid, and we know about life needs liquid water to survive. So you can say that the jury is still out. That's an extraordinary claim. We don't have extraordinary evidence. And you go to the gas giants, Jupiter, and it's so large that 1,300 Earths could fit inside of it. It's got a giant red spot that's bigger than Earth. There's a storm going on there in the red spot over 400 years, a remarkably interesting place with remarkably interesting moons, one of which is Europa, which has a liquid water ocean. Evidence is speculation, again, that life could exist under those oceans. We'd have to go there, we'd have to get under that ocean, these are the extraordinary evidence kind of things you need. Saturn, stunning gas giant, second in size only to Jupiter, with over 60 known moons. One of those moons, Enceladus, is spewing forth water vapor, steam, in tons and tons, hundreds of tons a day. How do you get steam, water vapor, in a place that is so cold everything should be ice, and there's no known heat source unless the heat source is internal? What's causing all that? But again, it's liquid water that's being heated up. So you get that, and it makes it interesting. Cassini is another moon that's got the methane lakes, perhaps a different kind of life. These are all questions. This is a great picture that you can see. I don't know if you can all see that. That's Earth peeking out from in between the rings from Saturn, taken by Cassini. Remarkable picture. Over there. And we look at some of these moons close up, and they're really no places. Lapidus looks just like the moon, even more rugged. I mentioned Enceladus here, and you can see the steam coming off on the left image at the South Pole. You can see an actual image of steam coming out. And Titan, Uranus is, I love Uranus because it's been so maligned and so how do I say it? Peed on is the best word. Because so the word itself, Uranus, especially if you're a school kid, you can make a lot of hay with Uranus. You could say Uranus or you could say Uranus. And it's been said both ways, and it's caused a lot of things, but guess who has the last laugh? Uranus has the last laugh. It's a place of mostly methane, 8 million times the pressure of Earth. This high pressure is speculated to compress carbon atoms in its atmosphere, causing diamond rainstorms, diamond lakes, and free-floating diamonds in those lakes. That's how amazing a place Uranus probably is. And here we have Neptune, about the same size, another gas giant, 4 times the size of Earth, 13 moons, 17 times the mass, 100,000 times the pressure. All these are very interesting places. And Pluto, of course, we've seen a lot from New Horizons from Pluto, and the interesting topography there, which really didn't make any sense. There's a movement to upgrade Pluto back to a planet, which probably should be done. Neil Tyson is responsible for downgrading it. Shame on him. I hope he takes it back. So when you look at all this astonishing diversity in our solar system, you get back to, is there life anywhere? We haven't found it. You speculated. How do we find it? We're going to go to these places sooner or later. We're going to have sample return missions. Or we're going to drill under the ice layer of Titan and bring back some of that liquid water. Or maybe we're going to put a robotic aqua vehicle down and to look for it. So it all gets down to this really question of, well, what is life and how do we look for it? So there are certain ways that science has developed to look for life. And the simplest one, of course, is the naked eye. We just look around. And then there are instruments like telescopes, spectrometers, and radio telescopes. That's another way we can look for life. And then we have our robotic emissaries, the bulk of which have been sent to Mars. And here we have other ones that have gone out into the universe: Voyager, Galileo, Viking, Pathfinder, Spirit, Opportunity, Cassini, Curiosity, and others to come, Insight. And all of them are designed to have instruments. Those instruments have jobs. So let's just take a look at the different ways that we can look for life and look at some of the fallibilities. Remember, extraordinary claims, extraordinary evidence, right? The first one is the naked eye. If ever there was an instrument that makes extraordinary claims, this is it. It's sitting under your hair and above your nose, and it goes from side to side, and basically it gets you in trouble in many, many ways. Mars is typical. First images that came back from Viking are in the lower right-hand corner, the face from Mars. And a lot of people believed an ancient civilization made this. After all, it does look like a face. We've written books about it, made movies about it. But when you come back and look at a different time with a better instrument, it's a pile of sand. And that's what it is. But we believe that's what we saw. Here's one on a cruise ship. I go on a lot of cruises and lecture on space extensively. So it's easy to find one like this. If you look at that through the window, you're going to see a UFO. Everybody see the UFO through the ballroom there? Just glaze on it. That's actually, of course, a chandelier that's reflecting in the window. But if you catch it a certain way, you can convince some people that you saw a UFO 4 o'clock in the morning. Then we have instruments on near-Earth spectrometers and telescopes that we put together. So one thing we do is we listen. Listening is the essence. Radio telescopes, listening is the essence of what SETI does, Search for Extraterrestrial Intelligence. We're listening for sounds of logic from all over the sky. So that's another instrument that we can use. And so far, SETI's been listening. It hasn't found anything. It's continuing to listen. Hope springs eternal. And let's just go to our robotic emissaries, because the robotic emissaries with Viking, they were trying to look for life directly. And I've already mentioned this before, but I'll sum it up here. How did How did Viking do this? Here's a picture of Viking, and you can see what it looked like. The image on the right was actually taken from the surface of Mars after landing on Cris Planitia in 1976. And the essence of Viking's logic to look for life was that a random plot of soil, just like on Earth, wouldn't contain a single elephant, but it would contain billions of microbes. So with that in mind, it dug down and it looked for microbes. And again, here's the respiration equation, and you can see food in the form of glucose, which is the end product of all of our digestion, combined with oxygen, forms carbon dioxide, water, and heat. And by the way, interestingly enough, if you run that in reverse, that's photosynthesis. Okay, so, but just keep that in mind. And the scientists in Viking were pretty incredible. They packaged all of this into something smaller than this table, all the instruments necessary to look for that. And the three experiments looked like this. There was the label the release experiment that I described that Gil Levin did. There was the gas exchange experiment, which looked for oxygen. And finally, there was the pyrolytic release experiment, which assumed there wasn't any water on Mars, and creatures would have evolved without the need for water. So again, all three of these experiments, in one form or another, were based on the respiration equation. And it seemed very logical. Scientists have taken a long time to derive this methodology of looking for life. And unfortunately, it didn't work out. One of them did, and the other two didn't, and they ganged up on them. And again, extraordinary, there was alternate explanations, chemical rather than biological possibilities that could have caused that data. So what happened then was NASA really was set back on its heels when it realized, well, we can't, putting all our eggs in one basket to look for life directly is difficult. So instead of doing that, let's look for the signs of life. And that became the mantra for the next decades up until the present day, where you hear the term, the search for water, follow the water. So all of the robotic probes that have been looking for life basically are looking to follow the water. And so they're also looking for fossils, and they're also looking for organic structures. And this hunt was motivated in part because of something that happened in 1984, which was the discovery of the Mars meteorite in Antarctica, otherwise known as ALH 84001. So if you look at this slice through the Mars meteorite, you see this structure here, which looks like a microfossil. And this tubular structure, and people looked at that. In fact, I still can remember Bill Clinton on television with David McKay, one of the scientists that I work with at the Johnson Space Center, and his team, saying that, hey, this is what life looks like. But we have learned from the past of having a single chain of evidence, because that's an extraordinary claim, and a single chain of evidence is not extraordinary enough. So we're going to have 4 separate chains of evidence to make it our claim that we found that this is life. And I won't get into the details of it, but there's been a book written about this called The Mars Meteorite, and it's a stunning book. It reads like a novel, and it takes you through these 4 separate chains of evidence that were used to make the claim that what you're looking at here was actually life, nanobacteria. But again, as what happens, a lot of scientists dissected these and came up with counterclaims for each one of them. And to this very day, there is no consensus about this being life. It shows how difficult it is when you make such a claim. You really got to climb a pretty high mountain to convince people. So the next thing is water. And we thought water was pretty much localized to planet Earth until we started looking around. And we've seen it on the moon now. We've seen it in Mercury. We've seen it on Mars. We've seen it in Enceladus. We've seen it in Titan. It's becoming, it's becoming more the rule in our solar system than the exception. And probably it's the rule in other solar systems as well. So that's a pretty good indication that life is certainly possible. Then the other way we look for life is with organics. Now, organics, that word is tossed around. What are organics? These are molecules containing carbon and hydrogen. They are not just carbon monoxide, just carbon dioxide, carbon tetrachloride, and they are not stuff grown without pesticides. They are simply carbon and hydrogen together. That's organic stuff. That's what we're made of. So we've looked for that, and we've found evidence of organic molecules on Mars and other places. Life beyond Earth. Okay, so because we've just touched our solar system. Well, life beyond Earth, if you go into the Milky Way, of course, Frank Drake came up with the famous Drake equation and calculated how many different places could harbor not just life, but intelligent life, intelligent survivable life. And you can go through the numbers of the Drake equation and come up with countless possibilities of life in our Milky Way galaxy. And don't forget, the Drake equation was just meant for our Milky Way galaxy. So let's just postulate a bit about these kinds of life, and you start speculating about them. And one of the things you can ask yourself is, if you find it, is it still there? If you go to the furthest reaches of the universe, 14 billion years, that's how long it's taking the light to get here. Several billion years closer, 3 billion light years away, 2 billion light years away. These are places where the light is getting here is billions of years old. You're looking at the past. You're looking at the ancient past. So what does all of this mean in terms of that life still being there? It may have been long gone. That's what makes it so difficult to imagine a UFO. It makes it so difficult to imagine anybody visiting us. To visit us, they would have to have a lifespan in the hundreds of years or more or greater. They would have to be able to surmount distances that are inconceivable, and then they would have to figure out where we are and come here, and our radio signals have only been pulsing out there for less than 100 years, which means if the way you look for life, like SETI is looking for life, anything beyond 100 years, there's no signal, there's no evidence of us. How would they even find us? So of course you could say, well, you're talking in today's, so here's the expert up on the stage, Lawrence Kuznets, blabbing all this stuff to you, right? And you could say to me, hey man, you're just giving me modern day physics. What about wormholes? What about this, that, and the other, multiverses? You're absolutely right. That's why I'm not an expert. And that's why all this changes and can change immediately. All I can do is kind of give you the state of things as they are at this particular moment in time. At the end of the day, what does all this say about the meaning of life and the existence of a higher power? So, at first blush, the evidence for this higher power looks pretty bleak. We haven't found anything yet. Every place we look appears desolate. The Bible makes no mention of anything beyond earth other than the heavens, which infers, of course, it was written by humans. The assumption of life and God then seems to be purely anecdotal. This is extraordinary claims. There is no extraordinary evidence. From a scientific standpoint, you would dismiss it. But there's a but. It's a hallmark of science to be skeptical, to be skeptical. But science has learned to use the word impossible with the utmost of caution. That was coined by Wernher von Braun. Things that seemed utterly impossible have proved possible to us. So that's another hallmark of science. And impossible is the calling card of a higher power. Some people call these miracles. So I don't have all the videos I'd like to show you because I wasn't prepared to do this, but I'll show you one that I find very compelling. It's not this one. Hopefully it is this one.
The brain is an amazing and complex organ. And while many people are fascinated by the brain, they can't really tell you that much about the properties about how the brain works because we don't teach neuroscience in schools. And one of the reasons why is that the equipment is so complex, expensive, that it's really only done at major universities and large institutions. And so in order to be able to access the brain, you really need to, dedicate your life and spend 6.5 years as a graduate student just to become a neuroscientist to get access to these tools. And that's a shame because 1 out of 5 of us, that's 20% of the entire world, will have a neurological disorder. And there are 0 cures for these diseases. And so it seems that what we should be doing is sort of reaching back earlier in the education process and sort of teaching students about neuroscience, and so that in the future they may be thinking about possibly becoming a brain scientist. And so when I was a graduate student, my lab mate Tim Marzullo and myself decided that, what if we took this complex equipment that we have for studying the brain and made it simple enough and affordable enough that anyone, an amateur or a high school student could learn and actually participate in the discovery of neuroscience. And so we did just that. A few years ago, we started a company called Backyard Brains, and we make DIY neuroscience equipment. And I brought some here tonight, and I want to do some demonstrations. You guys want to see some? All right. All right, so I need a volunteer. So right before, what is your name? All right, Sam. I'm going to record from your brain. Have you had this before? No. Okay. All right. I need you to stick out your arm for science. Roll up your sleeve a bit. All right. And so what I'm going to do, I'm putting electrodes on your arm, and you're probably wondering, I just said I'm going to record from your brain. What am I doing with your arm? You have about 80 billion neurons inside your brain right now. They're sending electrical messages back and forth and chemical messages. But some of your neurons right here in your motor cortex are going to send messages down when you move your arm like this. They go down across your corpus callosum, down onto your spinal cord, your lower motor neuron, out to your muscles here, and that is electrical discharge. It's going to be picked up by these electrodes right here, and we're going to be able to listen to exactly what your brain is going to be doing. So I'm going to turn this on for a second. Have you ever heard what your brain sounds like? No. All right, let's turn it on. So go ahead. Go ahead and squeeze your hand. All right, so what you're listening to, so this is your motor units that are happening right here. Okay, so let's take a look at it as well. So I'm going to stand over here. I'm going to open up our app here. So now I want you to squeeze. Yeah, so right here, these are the motor units that are happening from her spinal cord out to her muscle right here. And as she's doing it, you're seeing the electrical activity that's happening here. We can even click here and try to see one of them. So keep doing it really, really hard. Yeah, so now we've paused on one motor action potential that's happening right now inside of your brain. Okay. Do you guys want to see some more? All right. That's interesting, but let's get it better. Okay. I need one more volunteer. Okay. What is your name, sir? Miguel. All right. You're going to stand right here. So Miguel, when you're moving your arm like this, your brain is sending a signal down to your muscles right here. I want you to move your arm as well. All right, so your brain is going to send a signal down to your muscles. And so it turns out that there is a nerve that's right here that runs up here that innervates these 3 fingers. And it's close enough to the skin that we might be able to stimulate that. So that we can do is copy your brain signal that's going out to your hand and inject it into your hand so that your hand will move when your brain tells your hand to move. And so in a sense, she will take away your free will, and you will no longer have any control over this hand, okay? You with me? All right, so I just need to hook you up. All right, so I'm going to find your ulnar nerve, which is probably right around here. You don't know what you're signing up for when you come up and... So now I'm going to move away, and I'm going to plug it into our human-to-human interface over here. Okay, so Sam wants you to squeeze your hand again. All right, do it again. All right, perfect. So now I'm going to hook you up over here so that you get the stimulus. It's going to feel a little bit weird at first. This is going to feel like when you lose your free will and someone else becomes your agent, it does feel a bit strange. So I want you to relax your hand. All right, and Sam, you're with me? All right, so you're gonna squeeze. I'm not going to turn it on yet, so go ahead and give it a squeeze. All right. So now, are you ready, Miguel?
Ready as I'll ever be.
Okay, so I've turned it on. So go ahead and turn your hand. Do you feel that a little bit? No. Okay, do it again.
Oh, a little bit.
A little bit. Okay, so relax. No, hit it again. Okay. Oh, perfect. All right, so relax. Do it again. All right, so now. All right, so right now, your brain is controlling your arm, and it's also controlling his arm. So go ahead and just do it one more time. All right, so that's perfect. So now, what would happen if I took over my control of your hand? And so just relax your hand. What happens? Nothing. Why not? Because the brain has to do it. Now you do it again. All right, that's perfect. All right, well, thank you guys for being such a good sport. This is what's happening all across the world, electrophysiology. And we're going to bring on the Neuro Revolution. Thank you.
This is just one of many videos.
In 1931, Herman de Vries
This is just one of many videos that you can find that shows the amazing progress we're making in neuroscience. In another one, there's a chimp that watches a video screen that's hooked up to a similar system, and his brain signals are being sent over the internet to Tokyo, 3,000 miles away, to a robot that's on a treadmill. And this chimp has learned that if he walks on a treadmill, he can move the robot and get a treat for doing that. And it's just him thinking to move the legs of the robot. And of course, the ultimate benefit of all of this is if you have quadriplegics and paraplegics, you can literally bypass where the obstruction is, and they can learn to walk, and they can learn to use their limbs. And that's just the tip of the iceberg, because we can do the same thing with depression and Parkinson's disease. And neuroscience is opening up an incredible fast turn of events. And it's going to change the basis of who we are. And so when I think about what God is, I think about a spirit. And I think about that kind of power and that kind of knowledge and that kind of ability to fundamentally change who we are. That's really the essence of whatever you want to call as God or a spirit. So you can call it a miracle, but I don't call it that. This is what it really is. And I'd like to finish up with this, which is another way of looking at it. Hopefully this one will play.
You think this is just another day in your life? It's not just another day. It's the one day that is given to you today. It's given to you. It's a gift. It's the only gift that you have right now, and the only appropriate response is gratefulness. If you do nothing else but to cultivate that response to the great gift that this unique day is, if you learn to respond as if it were the first day in your life and the very last day, then you will have spent this day very well. Begin by opening your eyes and be surprised that you have eyes you can open. That incredible array of colors that is constantly offered to us for pure enjoyment. Look at the sky. We so rarely look at the sky. We so rarely note how different it is from moment to moment, with clouds coming and going. We just think of the weather, and even of the weather we don't think of all the many nuances of weather. We just think of good weather and bad weather. This day, right now, is unique weather. Maybe a kind that will never exactly in that form come again. The formation of clouds in the sky will never be the same that is right now. Open your eyes, look at that. Look at the faces of people whom you meet. Each one has an incredible story behind their face. A story that you could never fully fathom. Not only their own story, but the story of their ancestors. We all go back so far. And in this present moment, on this day, all the people you meet, all that life from generations and from so many places all over the world flows together and meets you here like a life-giving water if you only open your heart and drink. Open your heart to the incredible gifts that civilization gives to us. You flip a switch and there is electric light. You turn a faucet and there is warm water and cold water and drinkable water. It's a gift that millions and millions in the world will never experience. So these are just a few of an enormous number of gifts to which we can open your heart. And so I wish you that you will open your heart to all these blessings and let them flow through you, that everyone whom you will meet on this day will be blessed by you. Just by your eyes, by your smile, by your touch, just by your presence. Let the gratefulness overflow into blessing all around you. And then it will really be a good day.
I don't know that I can answer many questions about all that, but I hope you are entertained and learned something from all this, because I learned a lot in putting this whole thing together. I can try to answer any question anybody might have over it. Yes? I believe that there is a spirit that is in all of us, and that's my definition. I believe our ability to do these kinds of things is the essence of what I would call God. Other questions?
Any other questions for Lawrence?
Yeah, I can get that to you later. Yeah, sure.
Anybody else? Lawrence put this on the fly, by the way. If some of you came in later, he spoke for almost an hour here to fill in for a presenter that didn't show. So I'd like to give a big round of thanks to Lawrence Kuznets.
Kuznets.
And he'll be talking